Welcome to the channel. Here I have written a linked list example. These are the elements of a linked list, singly linked list. This is the element of singly linked list. 5 elements, 5 nodes you can say. Consider each element as a node. Okay. But here we have to start from first node and we have to move from last node in order to traverse. And if I have to move to second last node or third last node, uh, means if we have to move uh, to last node, we have last node pointer, you can easily access the last node pointer. But if I have to pop back, I have to move from 5 to 4 so that uh, I can delete 5 and make 4 to next pointer null. Okay. To do so, we have to start from first node and we have to move to second last node, that is n minus 1th node. Okay. Here on the screen we have only 5 nodes, but what if we have millions of nodes or hundreds of nodes, thousands of nodes? We have to make much efforts. We have to make more effort to in order to pop back. Okay. Pop back in a single linked list is big of an operation, an step operation. Okay. And one should avoid using frequently. What if I use if it was possible to move from last node to first node, we can easily move from both sides. This is, we can say, one way. This is one way. We can only go start from 1 to 5. We will go 1 to 5. But if I want to move from 5 to 1, this concept is not appropriate to do so. For this, I will use doubly linked list. Doubly linked list has uh, two ways: one for forward moving and second for backward moving. Means each node is linked by linked in two ways. Each node has the address of one address of the next element, and it also has the address of previous element also, so that we can move forward and backward easily. Let me show you. Suppose we have a node. It will have in linked list we have the structure of this kind of a structure, data. After that we have next pointer, okay. But in doubly linked list we also have the previous pointer that stores the address of previous element. Okay. Means you can move for start to last and last to start. Okay, both side. We have to move from here 5 to 4, we use previous pointer. 5 to previous will be 4. Okay. 5 to previous will have the address of suppose here last node is pointing to this 5. last node to previous will have the address of this fourth node that has 4 in data. Okay. Now we implement pop back function in the list. We can easily do this in constant time. Means if we have to delete 5, we will move from last node to previous here 4, and we will delete this 5, this element 5, and we will make 4 to next is null, 4 to next to null, and our list will be lesser, our list will be smaller. Okay, so let me show you how we implement the doubly linked list. Okay, here I have already written the structure of doubly linked list. Here I have a structure type pointer, that is pointer that is previous pointer, and pointer next, that is next pointer. It holds the address of next pointer, address of next element, and it holds previous hold star prev holds the address of previous element. Okay, and data holds the data element, okay, the value of data. Okay, now we will work same as singly linked list. We have just used another self-referential type data, and that is star prev, and I have initialized globally first node and last node to the null. I have pushback function and traverse function. Okay, let me write pushback function. If our list is empty, if both nodes are empty, first node equals null. And then we will have first node. First we will write, sorry, first we have to create a node. Let me create a memory space temp, that is uh, log size of list node. Now I have created a memory block, that is temp, and it is of structure type, and we will put some data. We will temp to previous. If our list doesn't have any element, this is at the starting node of doubly linked list, previous pointer will be null, and at the end the next pointer will be null. Okay, means we don't have any previous element, null. Okay, temp to data equals data, that is that data is given from the passed from the function. Temp to next equal null. Okay, now we will write the pushback function. First node, if first node equals null, we will assign first node equal temp, and last node, both node will pointing to the first node. Okay, both pointer will point first node. If we have only one element, both pointer will point to the first node, and after that we will return. Okay. Here, if if we have a list, if we have a couple of elements in our list, we have to uh, insert an element at the last. What we do, we will use temp to prev. We will modify this pointer temp to prev have the address of the last node. Okay. Now last node to next. Last node to next will have the data of temp. Last node to next will have the address of temp, and last node is now becomes the last node to next. Okay, this is how we write the pushback function. And we have traverse backward. We are moving from backward. Okay, here uh, if we have to move uh, forward, we have to traverse. Let me create a function for traversing forward. As our this is doubly linked list, we will create two traverse functions. That one is for backward traversing and another is for forward traversing. Let me give the prototype declaration. Okay. Here I will change. This is first node. And we will move to next. And here I'm moving from last node and by using prev pointer, and here I'm moving from by using next pointer. Okay. Now I have pushed 5 elements into the list. I will call forward. After that I will call backward. Let's run the code. Here you can see we have 5 elements. First we are moving to forward 1, 2, 3, 4, and the second traverse we are moving from backward from last to first node. Okay. Now if I have to uh, implement a white pop back routine, let me do this. White pop back if first node equals null, we will return. If first node Equals equals last node means we have only one node in our list. Here we will assign list node to pointer current node that will be first node. Sorry, uh, current node will be equal to last node. Okay. Now I have to delete a node if we have only one node, single node in our list. First node will be null and last node will be null, and will free current node, and we will return from here. And what if we have more than one elements? We will move current node last node will be now current node to previous. Okay. And last node to next will be null, and we will free the previous last node, that is current node. Okay, let me do this. Pop back one time. First I have inserted 5 elements, after that I have popped back. Okay, I've used pop back. Here you can see previously I have 5 elements, 1 2 3 4 5. Now I have 4 elements. If I use pop back again, 1 2 3 and 4. Now you can, here a list is now empty. Let me modify the function. Here, um, previously we have 5 elements, and after applying a pop, after popping each element one by one, we have now empty list. Okay, so you can see in the pop back function, and this is in doubly linked list, it is big of one operation, means yeah, it is constant time operation. We don't need to traverse list from first to last or anything. Okay, this is the benefit of using doubly linked list. Okay. Hope you understand the concept of doubly linked list. If you understand, please like my video, share with your friends, and thanks for watching. Happy coding.